Hello, fellow viewers. This is Prof. One Tutorials. My name is Alfred Amprofi, and I'm here again to help you learn another part of calculus. Calculus. Today, we are going to look at how to differentiate simple trigonometric ratios. Simple trigonometric ratios. How to differentiate simple trigonometric ratios. So today this is what we are going to look at. So I would like you to sit comfortably with your notebooks, your pens, pencils. If possible, you can add calculators so that in case there is any question where there is a need to use a calculator, we can all do it together. So sit comfortably and let's start. Basically, when you talk about the trigonometric ratios, we have two basic trigonometric ratios. That is the sine of an angle, let's say x. Then we have the cosine of an angle, let's say another x. These are the two basic trigonometric ratios. The rest that we have, they are all derived. They are all taken from these two trigonometric ratios. So we can talk about the tangent of x. We can talk about the cot or the cotangent of x. We can talk about the sec of x. We have the cosec of x. Everything that is, we have the tangent, the cotangent, the sec, the cosec, they are all derived. They are all derived. But today we are going to focus on the sine, the cosine, and the tangent. The rest, in our next video, we are going to look at how they were derived. All right. Now let's start from the tangent of x, for which we can just name it tan x. So the tan x is just the basic of it. So tan x, its definition is the same as sine x over the cosine x, or sine x over cos x. This is the definition for the tan. So tan is derived from sine and then the cosine. Now the cotangent, the sec and then the cosec, we are going to look at it in our next video. But today, we are not just going to look at just the definition, but how we can differentiate them. So now let's start with the sine. d dx of sine x. So when you are asked to differentiate sine, you can be asked to differentiate cos x. You can be asked to differentiate tan x. So we are going to look at just these three trigonometric ratios. Now, before we look at how they are differentiated, let's look at a general form. Generally, anytime you are differentiating a function containing a trig or containing trigonometric ratio, then when differentiating a trigonometric ratio, then d dx of sine f of x, then this is how we are going to do it. You are going to first of all differentiate the function we have here. So when you differentiate f of x, we are getting f prime of x. Then this f prime of x we've had here, we are going to use it to multiply the coefficient of the sine. But we know that the coefficient of sine here is 1. So f prime of x times 1, we still have f prime of x. Then it is going to multiply the differential of the sine. And when you differentiate sine, we are getting cos. Then cos of the main function given. So cos of f of x. So this is the general form. Now, let's move on to d dx of cos f of x. So just as we did what we have up here, when you want to differentiate cos of f of x, we are going to first of all differentiate the function. So we have f prime of x. But when we differentiate the cos itself, we are getting minus sine of the function given. So minus sine f of x. And here, because of the negative, we can just write it in front. So we have minus f prime of x sine f of x. This is going to be the differential. Now let's look at the last one, which is the third one. D dx tan f of x. Over here, when we are differentiating, we are going to differentiate the function, which is f prime of x. Then we are going to differentiate the tan itself. So tan, its differential is sec squared of the function, which is f of x. So basically, this is the general form. Now from here, let's look at what we have here. So when I differentiate the function, which is x, I am getting 1. Then I will now differentiate the sine, for which I am going to get cos, multiplying the function given, which is x. So here I am getting cos x. When it comes to this side, we have the differential or d dx of cos x. So from here, when I differentiate the function we have, it is x. So when I differentiate x, I am getting a 1. But when I differentiate the cos itself, I am getting negative sine, multiplying the function. So multiplying x. And this is the same as negative sine x. When you look at the third one, When I differentiate x, I am getting 1. Before I differentiate the trig itself, which is sec squared, multiplying the function, so multiplying x, and I am getting the same sec squared x. So basically, from these three trigonometric ratios, when we differentiate, this is what we are going to get. So my fellow viewers, we are going to look at some examples and how they are solved. So join me on the board. Example: find the differential of the following trigonometric ratios. A, y is equal to sine into bracket x squared minus 3x plus 1. So we can ask you to differentiate this or find the differential of this. So from here, dy over dx, because we are differentiating y with respect to x. So dy over dx is equal to, we are first of all going to differentiate what we have in the bracket. So when I differentiate x squared, I have 2x. When I differentiate minus 3x, I have negative 3. And when I differentiate 1, I am getting 0. Because 1 is a constant. Afterwards, then I need to differentiate the trig itself. And when I differentiate sine, I am getting cos. Multiplying the main function. So multiplying x squared minus 3x plus 1. So from here, we are just going to simplify. So we have dy over dx is equal to 2x minus 3 plus 0. We still have 2x minus 3. Multiplying cos into bracket x squared minus 3x plus 1. And this will be the final answer. Let's get the next question. B. Y is equal to cos into bracket 2x cubed plus x squared minus 1. So we want to differentiate this. So we have dy over dx is equal to, so from here we are going to start from the bracket, which is the function. So when I differentiate 2x cubed, we are going to get 6x squared, because the 3 here will multiply the coefficient of the x cubed, which is 6. Then I'll take 1 from the exponent, making 2. Plus, when I differentiate x squared, we are going to get 2x minus, but when I differentiate 1, I am getting 0 in a big bracket. Then I will now differentiate the trig itself. And when you differentiate cos, we are getting negative sine of the main function we have within the bracket. So we have 2x squared, 2x cubed, two x cubed plus x squared minus 1. So now we are going to simplify and get a final answer. So from here we have 6x squared plus 2x. Because of the negative, let me put this one in a bracket. Then I'll bring the negative here. So we have minus 6x squared plus 2x sine of 2x cubed plus x squared minus 1. And this is how it is done. The next question. C. We have y is equal to cos 4x cubed. Y is equal to cos 4x cubed. Dy over dx is equal to, so we are going to differentiate this first, which is the function. And when you differentiate 4x cubed, 3 times 4, we have 12. Then I'll take 1 from the exponent, giving us x squared. Then I'll now differentiate the cos itself, which is minus sine multiplying the function. So we have 4x cubed. Now, because of the negative we have here, we are going to write it in front of the 12x squared. So we have dy over dx is equal to negative 12x squared sine 4x cubed. And this will be the final answer. The next example. D. We have y is equal to sine 3x squared plus 1. Sine 3x squared plus 1. So we have dy over dx is equal to, I'm going to start from the bracket. So when I differentiate 3x squared, I have 6x plus, when I differentiate 1, we are going to get 0 because 1 is a constant. Then I'll now differentiate this trig, which is the sine. I am getting cos multiplying the function itself. So we have 3x squared plus 1. So from here, I'm going to finalize the answer. So I have dy over dx is equal to 6x, because 6x plus 0, we are still getting 6x, cos multiplying 3x squared plus 1. And this will be the final answer for this particular question. The next example. E. We have y is equal to cos cube x. Cos cube x. Over here, the trig is carrying an exponent. So from here, we have to make substitution. So we are going to let any variable of our choice represent cos x. So which variable do you want to use? Okay, let's use u. Let u be equal to cos x. So here we are going to differentiate u with respect to x. So du over dx is equal to, and we know that when we are differentiating, we are going to first of all differentiate the function which is x. And when we differentiate x, we are getting 1. Multiplying the differential of the trig itself, which is negative sign, then we add the x to it. So we have du over dx is equal to negative sine x. Then we have y is equal to. Now from here, we said we should let u represent cos x. But the original question was cos cube. So it's going to be u cube. Because u is now cos. So from here, we are also going to differentiate y with respect to u. So dy over du is equal to, when I differentiate u cube, we are getting 3u squared. Then from here, we are going to arrange and get the final answer. So dy over dx is going to be dy over du multiplying du over dx. Dy over du multiplying du over dx. So if you look at what we have done here, it seems like du takes off du, then it's going to be left with dy over dx, just as we are expecting it. So now let's look at how the final answer will be. So dy over dx is equal to, now we have dy over du to be 3u squared. 3u squared. Multiplying du over dx, we had negative sine x. So minus sine x. But we said that let u be cos x. So from here, we have the negative multiplying the 3, that is minus 3. Now our u is cos x, making cos squared x sine x. And this will be the final answer for this particular question. Let's go to the next question. F. We have y is equal to cos x plus sine x. Cos x plus sine x. So I'll make it y prime, because dy over dx is the same as y prime. When we differentiate cos x, we are going to get negative sine x from our previous calculations. plus, and when you differentiate sine x, we are getting cos x. So this can be rewrite as cos x from here minus sine x, and this will be the final answer. The next example, Jane, y is equal to 3 cos bracket open 5x squared plus 2. Now from here we are going to differentiate what we have from the bracket, multiplying the coefficient here. So we have dy over dx is equal to 3 multiplying, and when we differentiate 5x squared, the 2 will multiply the 5, making 10. Then with the exponent, we are going to take 1 from it, difference. So we have x exponent 1 plus, and when we differentiate 2, we are getting 0 because 2 here is a constant. Then we now differentiate the trig itself. And when you differentiate cos, we are getting negative sine, multiplying the function we have, which is 5x squared plus 2. So now we are going to evaluate them. So let me continue from here. Dy over dx is equal to, now first of all, I will write the negative. So I have negative here. Then 3 multiplying what we have from the bracket. So we have 3 multiplying 10x exponent 1. We are still getting 10x plus 0. We still have 10x sine what we have from the bracket, which is 5x squared plus 2. Now the final answer. Negative 3 times 10x, we are getting negative 30x. Then we continue with the remaining term, which is sine of 5x squared plus 2. And this is the final answer. H. We have y is equal to 2 cos squared bracket open x squared plus 1. And this will be the next example. Now from here, the cos is carrying an exponent. And anytime the trig is carrying an exponent, then we need to make substitution. So let any variable of your choice. This time around, we are using the letter A. So let A be equal to cos bracket open x squared plus 1. Then we are going to differentiate A with respect to x. So we have dA over dx is equal to, when you're differentiating a term like this, we are going to start from the bracket. So when I differentiate x squared, I have 2x plus, when I differentiate 1, I am getting 0 because 1 is a constant. Then I will now differentiate the cos itself, and I have minus sine multiplying the function which is x squared plus 1. So I have the a over the x to be equal to, because of the negative, I'll write it first. So minus 2x plus 0. I still have 2x. Then sine of x squared plus 1. Now, from here, this will be the continuation. So I have y to be, now we said that we should let cos bracket open x squared plus 1 be a. So y will be left with 2a squared. This 2 is here. Then everything here is representing a. But we know that the cos is squared, so we are getting a squared. So we have dy over dA. We are going to differentiate y with respect to a. Is equal to, when I differentiate this, I am getting 4a. So since we have this, then dy over dx is going to be dy over the a multiplying dA over dx. So we have dy over dA multiplying dA over dx. We are moving on. All right. Dy over dA, we had 4a. So we have 4a multiplying dA over dx. We had negative 2x sine bracket open x squared plus 1. But from here, we can multiply the negative 2 by the 4. So we have negative 8a multiplying x sine bracket open x squared plus 1. But we know that a is equal to cos of x squared plus 1. So we have dy over dx is equal to minus 8 multiplying cos of x squared plus 1, then x sine another x squared plus 1. So now let's put down the final answer by writing the x here, or attaching the x by the negative 8. So now we are going to get negative 8x cos bracket open x squared plus 1 sine x squared plus 1. And this will be the final answer. So we have the final answer to be minus 8x cos x squared plus 1 multiplying sine of x squared plus 1. The next example. I. Y is equal to tan squared x. Tan squared x. Here, the tan is carrying an exponent. So we are going to make substitution. So let m be equal to tan x. And from here, we are going to differentiate m with respect to x. So we have dm over dx is equal to, so when I differentiate tan x, I am getting sec squared x. Sec squared x. So now I have y to be tan squared x, but we know that tan x is m. So we are going to be left with m squared. Then from here, dy over dm is equal to, when I differentiate m squared, I am getting 2m. So now we can get the final answer here. So dy over dx is the same as dy over dm multiplying dm over dx. So from here, dy over dm is 2m multiplying dm over dx is x squared x. So from here, 2 is multiplying m. And from the substitution, m is tan x. So we have 2 tan x sec squared x. And this will be the final answer for this particular question. The next example, J. J. We have y is equal to 3 tan power 4 3x, 3 tan an exponent for 3x. So here the tan is still carrying an exponent. So we are going to let any variable of our choice, and this time around let's use a variable u is equal to tan of 3x. So u is equal to tan 3x. We are going to differentiate u with respect to x. So we have du over dx is equal to, when we are differentiating, we always start from the bracket or from the function. So when we differentiate 3x, we are getting 3. Then we will now differentiate the trig itself. And when you differentiate tan, we have sec squared multiplying the function 3x. Now y to be 3. From here, u is tan 3x. So we are going to get it as u power 4. So everything here is represented by u. So here we have dy over du to be, we are going to differentiate this. So 4 times 3, we have 12. Difference 1, we have u cubed. And this is my dy over du. So let's look at the final answer. Dy over dx is going to be dy over du multiplying du over dx. Dy over du multiplying du over dx. Dy over du is giving us 12u cubed. Multiplying du over dx is also giving us 3 sec squared multiplying 3x. Now from here, we have 3 multiplying this 12. We are going to get 36. And we have u cubed, but u is tan 3x. So it's going to be tan cube 3x. Then we'll continue with the remaining term, which is sec squared 3x. And this is going to be the final answer for dy over dx. The next example. K. Y is equal to cos into bracket x squared minus x. X squared minus x. So my cherished viewers, if you find this video to be very educative and helpful, kindly like this video, subscribe if you haven't subscribed to this channel. You can share your comments under the comment section and share to everybody. Right. Now let's get this particular example. Dy over dx is going to be, we are going to first of all differentiate from the bracket. X squared, we have 2x minus, when I differentiate x, we are getting 1. So the differential of x squared is 2x. When you differentiate x, we have 1. Then we now differentiate the cos itself. We are getting negative sign multiplying the whole function, which is x squared minus x. And because we have negative here, we are going to bring it in front of the whole term. So dy over dx is going to be minus bracket open 2x minus 1 multiplying sine x squared minus x. Our final example. L. Y is equal to sine squared multiplying x squared plus 1. Here, the sign is carrying an exponent. So you're going to use a variable to represent the sign in addition to the function. So let m be equal to sine of x squared plus 1. So before we can differentiate this, we have the m over the x is equal to, we are going to start from the bracket. When I differentiate x squared, I have 2x plus, and when I differentiate 1, I am getting 0. From here, I have to differentiate the sign itself, and I have cos multiplying the function. So multiplying x squared plus 1. So I have the m over the x to be 2x multiplying cos of x squared plus 1. Then my y is going to be, I represented everything here by m. So m squared. Then from here, I have to differentiate my y with respect to m. So I have the y over the m to be 2m, and this will be the differential. So now let's look at dy over dx. Dy over dx is going to be dy over the m multiplying the m over dx, dm over dx. So anytime we are multiplying like this take off that, and then at the end of the day, we are getting a final answer. So we have dy over dx to be dy over dm. We had 2m multiplying dm over dx. We have 2x cos x squared plus 1. So now I am going to substitute the whole m here. But before that, 2x times 2, I am getting 4x before I multiply by the m, which is sine bracket open x squared plus 1, multiplying the next, which is cos of x squared plus 1. And this is going to be the final answer for this question. So my cherished viewers, we will end here for today. And in the next video, we are going to look at the cotangent, how we can differentiate cotangent, how we can differentiate the sec and the cosec. So kindly subscribe if you haven't subscribed yet. Like any video you watch from this channel, you can share your comment or how you see this video in the comment section and share to your friends, your fellow colleagues, and I believe it is going to be very, very helpful. Stay tuned. Bye bye.